Hello. Sorry about that. I was having some difficulties. My previous stream was like not wanting to give me the end stream button for some reason, despite the fact that I cut off the stream. I don't know. At any rate, um, if you guys don't mind, I'm just gonna quickly check to see where we left off, because that was like a whole weekend ago, you know. So we were talking about tokenization. Okay. Good. Hmm. Hello? We're live? Good. Testing, testing, 1, 2, 3, testing, testing. Give people a minute to show up. So, how did the test go? I got the impression that a lot of people didn't do very well on the test. That was sort of my feeling. My feeling as I was watching people leave the room was that people were kind of like, "What just happened? Lol." That "What just happened?" Lol was like my impression of the mood in the room afterwards. Hmm. Well, normally, just as a procedure of in is my mic out? Hello, hello, testing, 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 testing. Hello, hello, hello. I can see the green bars up here. Yep. Okay, I can hear myself. All right. So normally, as a mental hygiene procedure, um, I don't I don't generally make like many speculations about. I don't generally speculate on the outcome of a test until I can, I have the actual hard evidence in front of me of how well people did on the test. Like it does occasionally happen that people think that I went 18 viewers in 302. Hi, 302. Um, I don't generally I don't generally get excited about tests or how well or poorly people think they did on them until I actually see how well or poorly people did on them. However, there was a lot of like people saying stuff like, "Oh, I got actually zero on this," going out of the test, which might be hyperbole. It might not be hyperbole. Um, we'll just have to wait to see what the results look like when we get the results. That's all. Um, but yeah, I will say that, like, I didn't think it was a hard test. That was not my impression going into it, was that it was, you know, kind of, there were a couple of tricky parts figuring out pointers and stuff, but that's kind of like, you know, I'm testing you on pointers, right? So, and pointers are tricky, so, you have to know something about pointers to be able to pass a C test, or to do well on a C test anyway. What happens if the marks are really low for the whole class? Well, I mean, then they're really low for the whole class, I don't generally curve tests. I don't generally curve test. I don't generally give marks out unless someone can demonstrate that the test was in some way unfair. So, like, if there was a problem in a question, I will absolutely compensate people with that, but, yeah, I was, I'm glad I gave you guys the extra half hour. Yeah, so just so that you and I are just so that we understand each other. I don't just set these tests like willy-nilly, right? I do have a process for determining how long a test should be. I think it's a pretty good system. What I do is I have the one or two, or however many, in this case 2 TAs wrote the test. I have TAs write the test blind, right? I have them time themselves to see how long it takes them to write the test, and then if that's, a sufficiently low fraction of the amount of time I was going to give you, then then I think that's a decent time for a test. So, like, in general, the rule of thumb in the mathematics department, and I think it also applies here, is that the instructor or the TAs, well, technically the instructor, but the TAs as well, should be able to write the test in 1/4 the amount of time that's given to the students. So this ended up being correct. Ali Reza wrote that test in 35 minutes. And when he was writing that, that was actually an earlier version of the test that he didn't have the benefit of the testing code. He didn't have the benefit of the testing code or the code stubs. He was just doing straight, like, C files from scratch, and he managed it in 35 minutes. I also had Ryan writing it, but and he took more on the order of like 45 minutes, but he also had a bad cold at the time, so I was like, well, if you didn't have a bad cold, probably you'd be able to shave, 5-10 minutes off of that. So when I saw that, I was like, well, maybe I'll give him an extra half hour. But yeah, so in general, I don't think the questions were unfair. There weren't any mistakes in the questions as far as I could tell. The announcements that were made during the test were more like gimmies, rather than, like, they were clarifications, but they did not, like, there was nothing in any of the announcements that, like, changed a question, if you know what I mean. Like, it's not like I was contradicting anything that was written in the test, written on the test paper. It was all like, hints, basically. So, I don't know. I don't think it was an unfair test. But again, we'll just have to see how the marks come out. So, would there be a redo / makeup? This is not the semester to ask for that. Oh, my God. Not that there's anything wrong with asking, but let's just say that I'm not sure I'm at liberty to divulge all of the details just yet, but there is this TA strike coming up, and let's just say that if the TAs go on strike, I require TAs to invigilate tests, right? So, yeah. If the class average is below 50%, would there be something we can do to boost our grade? I'll consider. I'll think about that problem, but you know, in general, sometimes I think it's, it's not a bad thing to fail a test every once in a while. But we'll just have to see how things progress. Again, I don't know what the average is, so I'm not going to make any promises. So, let's talk about our lecture material. So we were talking about conversion functions. We were talking about the string library, all very useful and interesting functions. We had just done a rundown of some of the C library functions, which don't get their own slides but are still worth mentioning. In particular, string token might be of particular use and interest. Here's a table with rough Python equivalents. Yeah. So here are a bunch of C functions. Here's approximately what your equivalent is in Python. Many of these Python functions actually map to the C standard library functions under the hood. So str2l maps to int conversion. snprintf maps to string conversion of an integer. String copy is approximately equal to copy.deepcopy in Python. String cat concatenation is mapped to the plus sign in Python. String length is just length of foo. String comparison, comparison operators, double equals, less than, greater than, etc. strchar, foo.indexBar, and strtoke is foo.splitBar. There you go. So, given that in C, data types are, as a concept, are somewhat ephemeral, it should be the case that the above operations on character arrays, or character pointers, should be reasonably generalizable. Ooh, actually, okay. That's one thing that I wanted to talk about that a lot of people had problems with on the test. Actually, now that this has reminded me of that. A lot of people on the test seemed to be under the misapprehension that a pointer and an array are the same thing. Like, for example, the two arguments to the first question, the two implicit arguments, a lot of people thought that these were arrays and were in some way related to the correct additions, correct subtractions arrays given in main. Unfortunately, no. While a pointer can indicate an array, it does not necessarily indicate an array. In those cases, those were just integer values being passed by reference, so they were just integer pointers and not pointers to integer arrays. I know this might be slightly my fault, because in class I sort of hammered quite a lot that arrays and pointers, like, if you take an array and you strip out all of the, all of the nice syntax, what you're left with is a pointer, right? An array is a pointer, right? So it's kind of like all arrays are pointers, but not all pointers point to arrays, right? So I just wanted to address that point, because I saw a lot of people having problems with that concept on the test. So string.h contains a set of memory operations which are highly similar to the operations on strings previously discussed. Rather than accepting and returning character pointers, these functions use void pointers. So of course you can cast them to whatever size, whatever you want, really. Memcopy copies n bytes from the object pointed to by S2 to the object pointed to by S1. So we've got memcopy, memmove, memcompare, memchr, or character, first occurrence of the thing, right? These are all, and memset, which is basically a write operation. So they're slightly different from the string operations, but in general, they do roughly the same things, just on general, like any data you want, not just characters. The one difference that you'll notice here is that the size must be specified here. In contrast to something like string character, or a string R character, we just have the string and the character we're looking for. In the equivalent memory operation, we also must specify the size of the thing that we're searching, because of course, if you remember, size of does not work on arrays once they've been passed into a function. That information is not kept native to the array data type. It's lost once you're outside of the current stack frame. So that the size of the whatever it is must be passed through as an argument to the function, which again is something that I noticed a few people getting wrong on the test. They forgot that size of cannot find the size of an array outside of the context in which that array has been declared. Okay, good. So let's move right along to format tags. Up to now, we have only briefly touched, or briefly touched, on the advanced features of the string formatting tag, %. We will now discuss the following features: rounding of floating point numbers and displaying a specified number of decimal places, aligning columns of numbers, right and left justification of outputs, exponential formats for floating point numbers, fixed field widths for various data types. All of the format specifiers we are about to discuss are used in printf, scanf, and their cousins. So this is an important section for question 2, I think, of the assignment 4. This, like, if you remember me telling a story at the beginning of class about how you should pay attention in class because it can save you a lot of hassle and heartache, I used an example where a student asked me what was wrong with their code because they were having a bug somewhere in their program, and like the instructor's solution to this problem was like 7 lines of code or something like that, and their solution was over 150, and it was like, I can't even begin to debug this because it's way too complicated for what you're doing, please pay attention to the slides and use the stuff that's in the slides, right? Well, it's this particular section that person hadn't paid attention to. While it is possible to do everything that you need to do, just treating strings as character arrays and performing, if statements and equality comparisons directly on characters, while that is possible, it is not efficient. You should rely on your standard libraries and your built-ins to be able to help you with these sorts of things. It's good to be able to fall back on if statements and while loops in any situation. That's a good skill, but it's also a good skill to, use the tools that are available to you. So, let's just quickly recap our format specifiers for integers. So, D, we should all know well enough by now. Signed decimal integer. I is also signed decimal integer. However, these are the same while printing, but different during scanf. O is unsigned octal. U is unsigned decimal. X is unsigned hexadecimal. And H, L, or LL are size modifiers which may be placed on any of these, right? So if you say LD, that's long signed decimal integer. If you say HD, that's short signed decimal integer, etc., etc. Mix and match. So, printing integers in various ways. This actually works best if I split this. I know this is a little small, but it works better this way, just trust me. So, there we go. That's better. So, print statement, what it prints, right? D, regular, we should all know this. I, fine, the same. If you've got a plus on the number, it doesn't print. If you've got a minus on the number, it does print. A short prints as a short. A long prints as a long. If you put the L suffix on the end of a literal, that turns it into a long integer literal. 455 in octal is 707. Unsigned does nothing to positive integers, but printing a negative number as unsigned will reveal what it looks like inside of 2's complement. I'm pretty sure I did 2's complement. I'm pretty sure I did 2's complement with you guys, so you guys should remember, I hope. And then, of course, hexadecimal. Lowercase x prints the letters lowercase. Uppercase x prints the characters uppercase. Cool. Boom. So let's talk about floats. So F prints in decimal point notation, by default to 6 decimal places. F is supported in Microsoft Visual C++ compiler and Visual Studio 2015, which dates the textbook, doesn't it? And higher. So E displays in exponential notation, so that's like, 7.38 e negative 5, right, instead of times 10 to the. G will intelligently select between E and F depending on how far, depending on what the magnitude of the value is. And of course, putting the L in front specifies these as being long doubles. So, taking a look at some more print statements. Oh, it's actually on the same page. What am I doing? What am I doing? What am I doing? So printing with the E format tag, this is what we mean, right? It's 1.234568 E 6, right? Notice that the 7 has been rounded up, right? Capital E just puts capital E in there. The minus signs print, but the plus signs don't. F prints to 6 digits regardless of the magnitude. Since, in this case, G is, like, the magnitude of the number is sufficiently large, G will select E. And notice that it prints with truncation rather than a rounding. Oh, pardon me. Need more tea. E and F show 6 digits of precision by default. F will always print at least 1 digit to the left of the decimal point. G will select E if the exponent would be greater than the specified precision, default 6, or less than -4, and F otherwise. G does not print trailing zeros. E and G display rounded values. F displays truncated values. Random trivia. You can print the percent sign character with either %%, with %%. Note that /% doesn't work. So, working with field widths. Have you ever been bummed out because getting C to print a table of values with properly aligned numbers is hard? Fear no more. Inserting an integer value between the %sign character and the format specifier sets the field width. Data will normally be right justified within this field. Field widths may be used with all format specifiers. Didn't G give truncation in the example? Indeed it did. That might be an error in the textbook then. Well, so it goes. If your field width is too narrow for your data, that data will overhang the specified width rather than being truncated. So this is a useful thing to know, because there's a bit in the upcoming assignment where you're supposed to read in date formats, right? Now, I get a lot of complaints about this question because essentially, like, I get a lot of complaints coming back after the assignment has been marked because people, like, just output the date in, you know, any old format and you know, expect, like, I got the right numbers, so I got the right solution, right? And it's like, no, the whole point of that question is that you're learning to format strings correctly, right? Which means if your output doesn't match the expected output correctly to the character, then it's not correct because you haven't been working with the characters correctly. So, well, look it up in the standard documentation, right? I gotta keep moving. I gotta keep moving on this. That's something that's easy enough to test for yourself. So, in all of these cases, we now have 4 characters of field width specified by the format tag. So printing things up to and including 4 characters in size. You can see we fill the column from the right to the left, right? However, as soon as we have one more character than will fit inside this space, we have that one additional character overhanging, right? If we have the negative sign, of course, takes up space as well. So we actually hit 4 characters at negative 1, 2, 3 instead of 1, 2, 3, 4. So you can see by the end of this line, we're overhanging by 2 characters. We can specify various things for different data types using the .x format tag, where x is a number, right? So in addition, so we've talked about field widths. We can now talk about the precision, right? When applied to integers, leading zeros are included instead of spaces to fill the field width. When applied to floats, this controls the number of decimal places that are displayed, i.e. the precision. So, there's, I know this is Python, but Python has an interpreter, and it's a little bit faster to show this. And Python, in general, uses the same format tags as C because it's a C-based language. So if we have a number like 0.1, right? I've shown you this example where, like, 0.1 plus 0.2 is not equal to 0.3, right? Because of floating point error. We've talked about floating point error. If you format, and this is using format tags, right? Basically, this is like specifying a C format tag and applying it to a number in Python, right? So this is like, you know, if you print 6 decimal places, you can print 10 decimal places, you can print 60 decimal places. If you print 60 decimal places, you can actually expose the floating point error that's inherent in the format, inherent in floating point arithmetic. Right? So, and using that, you can see why 0.3 is not equal to 0.1 plus 0.2, because take a look at that, right? But yeah, so you can specify how many decimal places you want to print. In general, because floating point arithmetic is floating point arithmetic, nothing past 15 or 16 decimal places, depending on the number, is going to be useful, because it's going to be just that random garbage that's added by floating point error. Good. When applied to strings, it sets the number of characters to display. The rest of the string will be truncated. The S tag looks for a null terminating character. If you aren't careful, %S can produce a segfault. Using %S instead of %C by mistake can also cause this. So basically, if you're so %S requires null termination in order to stop printing characters. If your thing is not null terminated, then printing it as a string might result in a memory error, and it will certainly result in garbage. So if you're trying to print a character as a string, just a single character as a string, possible segfault. If you're trying to print a string as a character, though, what you'll probably end up with is well, you'll also end up with a problem because it will think that you're trying to print a pointer as a character, and you might get some random garbage. It'll probably cut off the top half and just print the lowest 8 bits as a character. Specifying a field width is an effective countermeasure against non-null terminated strings. So if you specify that the string should only be so long, then if it does happen to, go into memory that doesn't belong to the string, then hopefully it'll stop before it hits memory that doesn't belong to your program, which will cause a seg fault. Boom. So, specifying precision for integers, we've got 0.4D and 0.9D, both printing 873. You can see the first one, 0873. The second one with 6 zeros in front, 873. Using precision for floating point numbers, 0.3F, 0.3E, 0.3G, all on the number 123.94536, 1.945, 1.239E plus 2, and 124. So notice that G, right, is just giving the number of digits, not the number of decimal digits. And using precision for strings, if we specify that happy birthday should only contain 11 characters, then we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Boop. Happy birth. Which is slightly funny. So, in addition, there are a number of flags that may be included to modify the print format. Minus sign produces left justification within a specified field. Plus sign indicates that you should display the plus sign preceding positive values and a minus sign preceding negative values. So that's basically a accountancy view. You know, most people don't put the plus sign in, but accountants will. So that's like, you gotta remember that like a lot of the early applications of computing were like, you know, accountancy software that was running in terminal without a GUI, right? So like a certain amount of this is like helping, you know, helping that sort of thing. So space prints a space before a positive value, not printed with a plus flag. So if it's kind of, if you want the space held by the plus, like if you want the space that the plus sign would be in to still count as a space so that everything lines up with negative numbers, you put a space in. The pound sign, or octothorpe, prefixes 0 to the output value when used, with the octal conversion specifier. So basically that prefixes your format specifier for integers. Force a decimal point for floating point numbers printed with E, F, G, or G that do not contain a fractional part. Normally, the decimal point is only printed if a digit follows it. And 0, pad a field with leading zeros. So there you go. Lots of options. Just in the interests of time, I'm going to skip I'm going to skip this section on selected scan sets, or, you know, basically using scanf, it's possible to restrict the characters which are read to a particular set of characters. This is known as a scan set. You use square braces for this. Personally, I normally have difficulty getting it to actually work properly, so why don't we just you know, slide through that without worrying about it too much. So yeah, any questions about any of that before we talk about file I/O? Give me a thumbs up if you're good. Give me a thumbs down if you're not. And, did they do file I.O. with you guys in 1D04? Or 1P13 or whatever the heck they're calling it these days? Hopefully. I mean, I can't quite imagine any programming course, particularly an introductory programming course, not doing file I.O. a bit. Only a little. Like, define only a little. Presumably you know how to open a file, read stuff from it, write stuff to it. Am I wrong there? Everything was provided to us. We just had to type a couple of things into Python. Everything was provided to us. We just had to type a couple of things. Like, open, close, read, write. Okay. All right. Well, all right. A little bit in iBio 1P10 as well, but not much. Well, you know, that's great for the iBio kids, but for the rest of you poor sots, the, shall we say, biologically uninterested, you know, well, we'll see how things go. So, in general, all right, file I.O., that is to say file input and output, operates in C almost exactly the same way that file I.O. operates in Python. This section will assume that you at least vaguely remember how to do this in Python. So, in general, what happens, you specify a file in your file system to open. You call an opening function on it, in this case, fopen. That will return a file handle, right? Now, in C's context, the file handle is actually a pointer to a pointer to a structure. We're going to talk about structures soon. A file structure, which is defined in stdio.h. So all of these operations are defined in standard io.h, as you might expect. File IO being part of standard IO. So the file structure contains all information relevant to the file that's currently being streamed, right? So the file stream, you receive data from it while you're reading the file. You send data to it when you're writing a file, and you have to remember to close it at the end. Now, this is kind of like the same way that you need to remember to free your pointers at the end of. You need to remember to free your pointers for the same reason that you need to remember to close your files when you're finished with them. When you open a file, the operating system gives you exclusive rights to the access of that file while you have it open. If you do not relinquish said rights, it's bad form. The operating system has to basically you have to wait until the operating system notices that your program has closed or whatever and rudely didn't relinquish its resources to the operating system. That's like the correct way to view files in the file system, is as resources available to the computer that you have to reserve for yourself. But anyway, so let's talk about fopen. Opening a file stream requires invocation of fopen. So here is your Here is your format for that. First of all, we are returning the file pointer, the file handler pointer. Our first argument is the string file name. It's constant char. As you may expect, file name is a string containing the name of the file to be opened. The file may be specified by either absolute or relative addressing, which everybody should have at least a slightly better familiarity with, since I've been making you do all of this Git nonsense. Mode is a string specifying, among other things, whether the file will be opened in read or write mode. So far, so Python. If you just take the F off of this and, ignore the fact that this is a struct instead of an object, this is actually so far exactly the same way that Python works. It just has a semicolon. Oh, question. Does writing to the file clear its contents like it did in Python, or does it add on to it? Well, it depends on what mode you specify, my friend. If you specify read mode, then you can't. If you specify write mode, then it's overwrite mode, right? So yes, under write mode, the contents of the file are destroyed. However, there is append mode. So you can specify append mode as well. Open or create a file for writing at the end of the file, i.e., write operations append data to the file. So if you just want to, anything you write goes at the end, that's append mode. And incidentally, Python also has append mode. All that Python is doing in the back end is calling this function from the C standard library. So all of these are the same option specifiers that you would have available to you in Python. Same gosh darned ones. Precisely the same. So, F close, but no cigar. Some of these puns are really bad. I'm just going to put it out there. Just as dynamically allocated pointers need to be freed when they're no longer needed, a file stream must be closed when you're finished with it. So, it's very simple. F close file stream. This one's pretty straightforward. Takes the file stream as an argument, right? So you just give it the pointer to the file object, or to the file struct, and it closes it. Returns 0 on success and end of file character on failure, or the end of file code. So there you go. fscanf is difficult to write a pun for. I could have thought about it harder though. If anybody can think of a pun for fscanf, please put it in the chat now. If you want to treat your file like you are reading information from standard input, you could use fscanf and fprintf. So fscanf, your first argument is the file stream, but past that, all arguments are exactly the same as regular scanf. While the first argument is, I just said that exactly. The return value is the number of input items successfully matched and assigned, i.e. the number of format specifiers in the format string that were successful. Question: what is the stream pointer? So, good question. Do you remember in Python how when you, let's see here. Do you remember in Python how when you used the open function, you did probably something like fh equals open. Let me just do it in the text editor. So, ugly Python. So file handle is equal to open myfile.py in read mode, or something like that. Beautiful, magical C. In this case, you say something like file pointer file handle is equal to fopen, and we're going to have examples of this later on, of course, but file open myfile.c in read mode, semicolon. So in Python, this is an object, right? This is an object that's instantiated from a file handler class because it's an object-oriented language, and that's how it do. But in this case, in C, it's a struct that's contained in standard I/O, but you really don't have to think about it very hard. All you really need to do, like for example, if you were to, use this for scanf, you just fscanf file handle, and then your regular whatever you're doing, say reading an integer and then storing it in foo, right? Does that make sense? The equivalent in Python would be something like foo equals fh.readLine. Except it's not quite, but... So the stream is the file handler. Yes, it's the file stream. File, stream. File stream. It's kind of older terminology, but yeah, the file stream and the file handler are the same concept. Any other questions? Oh, Jesus. Okay, I just got an email from the our department head, Dr. Mark Lawford. Apparently the Go bus drivers are on strike. It's like, is everybody on strike? It's like we just get over the pandemic and we have all of this pent up like strike energy that nobody's been able to express for 2 years. So everybody's striking at once. My God. Okay. Do you need to define foo, or does it automatically get defined at scanf? No. Nothing ever gets automatically defined in C. No, you need a declaration line for foo. Just like that. Strike season. Yeah, Jesus. Don't even get me started. Students on strike. I wouldn't be surprised. It might not be a bad idea for you guys to go on strike once you hear how things are going to be handled with respect to the TA strike. It's not going to be pretty. I'm going to have, I'm having a meeting about it today, but basically this week I'm going to have to, I'm probably going to have to publish some plans to, to avoid the, to deal with the TA strike is going to require quite a lot of planning, and frankly, some services are going to have to be cut. So we'll see how things go. We only used to use file I/O on text files to get data. What kind of data would you be able to get if you were to use file I/O on file I/O on C files, like you showed in the example? Oh, like on C source code files? Yeah, you could, like, well, anything you want, really. Yeah, like, you know, to be honest, like, the applications of C files are, like, not, there's not a lot of reason to do C files. I sometimes do an example, in, like normally I do these examples mostly in my Python class, and I'm working on Python source code files, but, like, you can do examples where, like, you remove all comments from a file, or you remove all blank lines from a file, you know, stuff like that. Yeah, no, mostly it's getting data that's important. Comma separated value files are a pretty good one to know how to read, just kind of in your daily life. But anyway, yeah, contingency plans. You have no concept. Well, maybe you do, but yeah, contingency plans. Holy hell, are we going to be dealing with contingencies? I really just hope the TAs don't go on strike. That's my that's what I'm hoping for. I'm hoping for the 11th hour ex machina that's going to fix the problem so that I don't have to do all of everything myself, because that's currently what the plan might be, and that's just not going to work because I got 650 students. So, yep. All right. All right. Well, see you later, sports fans. I'll talk to you guys tomorrow.